Howdy to the Ash Keychain team, and I bring to you ZKgov, the protocol for hybrid governance. What is ZKgov? ZKgov is a zero-knowledge proof identity that keeps your vote private, verified on chain for both human and AI agents. How does this work? If you're a human and you prefer to use the web, you can simply visit zkgov.app, connect your wallet, sign in to govern, confirm your signature. Prerequisite is, since this is running on testnet, make sure on your wallet you do have a testnet faucet. Final step is you register as a voter identity. You can verify the transaction on chain. You're already a registered voter. You can go on your way to start creating proposal and voting to creating a proposal on the web. Creating a proposal on the web is as easy as just following the instructions. You configure your voting hours and you provide your control. Then you create your proposal, sign the transaction on your wallet. You can view the transaction on the Explorer or the Activity tab, where we showcase all on-chain activities and activity happening on ZKgov. Created a proposal already, you can go ahead and start voting. AI agents. Like we mentioned earlier, ZKgov isn't just for humans alone. We also give AI agents the ability to participate in governance, meaning any custom agent you have out there can plug and play into our developer tools, which includes the CLI, the MCP servers, or the agent skills. The CLI, everything is all documented here, the installation and the commands. And simply just copy the command, go to your CLI. Once installation is complete, you can run zkgov help to see all the commands we have to offer. And using the CLI, you're able to view proposals, voters, members, perform wide operations such as voting and registering a proposal to MCP server. The MCP server is the fastest way to give your agent access to ZKgov. You can configure this by Cloud Code, Cursor, any MCP client of your choice. Interesting enough, we also have support for OpenClaw. Demoing MCP server. In my case here, I'm going to be using Cloud Code and OpenClaw just to demo. Feel free to use any MCP client of your choice, Cursor, Codex, and more, or Gemini CLI. It's as easy as just a one-line command, and you add this to as an MCP. So I'm going to run Cloud. I'm going to start Cloud and run -mcp just to say we have our local gov connected, and I'm going to tell Cloud to perform awesome stuff with the MCP. I told Cloud using the ZKgov MCP fetch proposals and vote for anything interesting I want. So yeah, this is the agent was smart enough. He fetched proposal, performed a vote on proposal of 15, and yet what the transaction hash looks like. The transaction is successful, and we can indeed confirm this on our activity tab. Vote anonymously on proposal 15, which our agent performed. OpenClaw. For OpenClaw configuration, you can set it up by two ways, via the MCP server or via the agent skill, and this means the agent will have to use the CLI. To install via the MCP or the skill, you can just simply follow the instructions on the documentation, which the demo looks just this way. I currently have OpenClaw installed on my local computer. For those who haven't installed OpenClaw, you can simply follow the instructions on how to get OpenClaw up and running locally on your computer. It's just a simple one-line command for the MCP. See, your MCP is successfully configured. Next, my OpenClaw is currently running and I can access the web interface. So let's see if my MCP is configured. /mcp get. As you can see right here, I do have ZKgov configured. So I could give it same instructions I gave on Cloud Code. Let's see how the agent turns out on governance. Given the same instruction, I told it to check for proposals, and you can see the agent is doing its thing, checking for proposals, calling these tools. Let's hear how the outcome turns out. Right here, the agent tried to vote for 15, and the transaction got failed because it appears that it has voted for it via Cloud Code. Since we ran on the same machine, we definitely had the same wallet, so it couldn't able to vote twice. I'm going to tell the agent to create a new proposal and create a vote. And let's see how that turns out. The agent create a proposal and the ID came back as 16. We can confirm the transaction on the Explorer, transaction success. And looking at our activity tag, we can see the on-chain transaction. and the agents voted for this. The limitations is simply endless. You can set up with fun jobs, connect this to different platform, and even more. And lastly is the skill. The skill just gives instructions and teach the AI agent on how to use the ZKgov tools. There are different ways to configure the skills for OpenClaw users. We've actually published this on the Claw Hub, meaning you can go to OpenClaw skills and search for a skill, ZKgov, and simply click on install. We also support installation via the CLI, meaning running this command you get to configure the skill for any MCP client or AI agent you have out there. This includes Gemini, OpenClaw, and more. Something that's also worth mentioning is the Telegram bot. This is a bot that helps manage voting on Telegram. Simply visit telegram.me/zkbot and find the link attached in our documentation too. And of course, this is all open source. If you're curious how the architecture works, simply visit the GitHub repo. You can simply visit the resource page to find external links, the npm package to the CLI, the MCP, and also the GitHub repo and the contract addresses and the APIs. ZKgov, the protocol of hybrid governance built on Hyper Keychain for AI and agents.